Hello, my students. Welcome back into my channel. In this video, I'm going to explain how we solving a past paper, Cambridge International AS&A level past paper, Mathematics, Paper 3, Pure Mathematics 3, number 970931 on October-November 2023. Let's start. Number 1, find the exact coordinates. Coordinates point means, exact coordinates of the points on the curve y equals x squared over 1 minus 3x, at which the gradient of the tangent is equal to 8. Gradient of the tangent, it means dy dx, or derivative of this function. Okay, to find this derivative of this function, I'm going to use a rule that if y equals u for v, so dy dx, or derivative y, equals derivative u times v minus u derivative v over v squared. Yeah. Now let u equals x squared. So derivative u equals 2x. And if v equals 1 minus 3x, derivative v equals minus 3. And v squared, 1 minus 3x squared, it is 1 minus 6x plus 9x squared. So based on this rule that dy dx, we can determine 2x times v, 1 minus 3x, minus u x squared times derivative v minus 3 over v squared over, I'm going to writing 1 minus 3x squared. Then it becomes 2x minus 6x squared plus 3x squared over 1 minus 3x squared becomes 2x minus 3x squared over 1 minus 3x squared. Yeah, that is dy dx. Gradient of the tangent is dy dx, or the derivative. So it means dy dx equals 8, or this equal 8. This expression 2x minus 3x squared over 1 minus 3x squared equals 8. And it becomes 2x squared. We expand this. Sorry, 2x, not squared. 2x minus 3x squared equals 8 times, I'm going to expand this like this one. Okay, this expression being 1 minus 6x plus 9x squared. And this equation becomes 2x minus 3x squared equals 8 minus 48x plus 72x squared. So the next step is 72 minus 72 plus 3, 75x squared minus 50x plus 8 equals 0. Factorize 15 times 5. 8 is 4 and 2. So 2 here, 4 here. Okay. Equals 0. So 15x equals 4 or 5x equals 2. So x equals 4 over 15. X equals 2/5. Now, if x equals 4, 15, y equals, based on this function y, this x squared over 1 minus 3x. 4 over 15 squared, 1 minus 3 times 4 over 15 becomes 16 over 225. 1 minus 12 over 15. 16 over 225 over 15 minus 12, 3. 15. So 16 over 225 times 15 over 3 becomes 15, okay? And 15 times 3, 45. So 16 over 45. So if x equals 4 over 15, y equals 16 over 45. So how about if x equals 2 over 5, y equals 2 over 5 squared over 1 minus 3 times 2/5, like this, becomes 4 over 25 over 1 minus 6/5 equals 4 over 25 times, this is minus 1/5, because 5 over 5 minus 6 over 5 equals minus 1/5. So times minus 5 over 1 comes minus 4 over 5. So if x equals 2 over 5, y equals minus 4 over 5. Number 2, on an Argand diagram, say the region whose points represent complex number z satisfying the inequalities modulus z minus 2i less than or equal modulus z plus 2 minus I and 0 less or equal argument z plus 1 or argument z plus 1 between 0 and pi over 4. Okay. So we are going to sketch this. If we will sketch this based on the rule of complex number rule, that this is axis for imaginary and this is axis for real number. This for imaginary number. So imaginary number similar with y-axis and r-axis, not similar but same with x-axis, right? So modulus z minus 0 plus 2i less than or equal modulus z minus 2 plus I. I create like this because I will determine the coordinate point. Yeah. And argument z minus 1 minus 1 plus 0 I think less than or equal 1 over 4 pi. Okay. Now from this one 0, wait, from 0 plus 2i, we get the coordinate point 0, 2. And from minus 2 plus I, we get the coordinate point minus 2, 1. Okay, this minus 2, because this is at real axis and this one at I-axis. Okay, then next, from minus 1 plus 0i, we get coordinate point minus 1, 0. And the next, from minus 2 plus 0 over 2 plus 1 plus 2 over 2i, we get coordinate point minus 1, 3 half or 1 half. Okay, 1 half. Okay, minus 1, minus 2, minus 3, 1, 2, 3. 1, 2, 3. And firstly, 2, this one, yeah. 0, 2, 0, 2, 0, 2 here. And after that, this minus 1, and 3 half, minus 1 and 3 half here. And then this one, minus 2 and 1 here. Because I'm going to use another color, a different color. Yes, that -1, this. So I will create a straight line, okay, like this, and then another straight line through this coordinate point, which perpendicular. Wait, nice. Yeah, perpendicular here. Okay, so next, we're going to shading this area if. Okay, yeah. Don't forget this angle. This angle is angle for 1/4 pi, and this the straight line of argument z plus 2 minus y. This is the straight line of z minus 2 z minus 2i equals z plus 2 minus I. Yeah. Okay. And now, uh, of course, you have to check this origin 0, 0 if you substitute into this equation. Okay, if 0, 0, you have to say based on the rule that you have to setting. I'm gonna use yeah. You have to setting this area. Okay. But you have to substitute first uh, this current point 0, 0 into this equation. Next, for this equation, you have to substitute as well 0, 0 into this, and uh, the result you have to shading this area. Now, why under under 0 you have no need for us to shading, because this area is not the solution area. Okay, so all of these I number are positive number. Okay, so this the area, the blue, the crossing of blue color, that is the area of solution. Number 3, okay, through this graph, the variables x and y are related by the equation y equals ab power x, where a and b are constant. A and b are constant. Okay, the variable is x. The diagram shows the result of plotting ln y against x. Okay, so look at this axis for ln y, and this axis, the horizontal axis for x, and the vertical axis for ln y, right? For two pairs of values x and y, the coordinates of these points are 1, 3.7 and 2.2, 6.46. So this is 1, 3.7, while this one is wait, yeah, 2.2 and 6.46. 6.46. Okay. Use this information to find the values of A and B, right? The function y equals AB power x. So it means if I'm going to using learn because of the x is learn y, so it means learn y equals learn AB x, like this. Or based on the learn rule, it becomes learn A plus learn B power x, or learn y equals learn A plus x learn B. Now, based on the straight line equation, based on the straight line equation that learn y is y, the straight line equation like this, c plus mx, or y equals mx plus c. This is the straight line equation. So it means y equals ln y. Mx equals x ln b, and then c equals ln a. And recall that the coordinate point 1, 3.7 and 2.2, 6.46. So it means gradient or m, and gradient is 6.46 minus 3.7. So actually we can create a straight line through this coordinate point, and we can find the gradient of this straight line. Okay, this is y, delta y. This is delta x. So delta y over delta x. This over 2.2 minus 1 equals 2.76 over 1.2 equals 2.3. That is the gradient. So learn B based on this information. Okay, learn B equals mx. Yeah, learn B equals 2.3. Yeah, right. 2.3. So B equals e power 2.3, 9.97. And next, y equals c plus mx, y equals 3.7. Because on this coordinate point, 1, 3.7, x equals y, x equals 1, y equals 3.7. Yep. So this equation being 3.7 equals c plus plus 2.3 times 1. X equals 1. So it means c equals 3.7 minus 2.3 equals 1.4. Yeah. Ln A equals 1.4. It means A equals e power 1.4 equals 4.06. So A equals 4.06 and B equals 9.97. Next, number 4. The complex number u is defined by u equals 3 plus 2i over a minus 5i, where a is real. Okay. Express u in the Cartesian form x plus iy, where x and y are in terms of a. Okay, u equals 3 plus y over a minus 5i. I will multiply by a plus I over a plus I. And it is going to be 3 times, 3a plus 15i plus 2ai minus 10, because I squared is minus 1. So 2 times 5, 10 times minus 1 equals minus 10. Okay, over a squared minus 25. Yeah, because minus becomes plus. Becomes plus because I times I is negative 1. Negative times negative equals positive. Right. So I would like to write down this fraction becomes like this. I'm going to separate the a minus 10 and then plus 15 plus 2a times I factorize over a squared plus 25. Okay, so I can write it like this. 3a minus 10 over a squared plus 25 plus, 15 plus 2a in brackets over a squared plus 25i. Right. So this is x, this is y. X. Be given that argument u equals 1 over 4 pi, find the values of a. So if argument u equals 1 over 4 pi, we're going to find a. Argument u equals 1 over 4 pi. So it means tangent tangent power u equals 1 over 4 pi. Right, I will explain first here that if tangent u equals imaginary number and real number. So the imaginary number is 15 plus 2a over sorry. I mean like this. The imaginary number is 15 plus 2I over a squared plus 25. Okay, this part. While real number is this part. Real number and imaginary number, or x and y. A real number, a minus 10 over a squared plus 25. So it means tangent power minus 1u becomes like this. I'm gonna writing like this. Based on this information, that becomes imaginary 15 plus 2a over a squared plus 25 over 3a minus 10 over a squared plus 25 equals 1 over 4 pi. Or it's going to be, if we multiply, becomes, it divided becomes 1. So 15 plus 2a over 3a minus 10 over equals 1 over 4 pi. So it means 15 plus 2a over 3a minus 10 equals tangent 1 over 4 pi. Because this is tangent power negative 1 or arctangent or inverse. And tangent 1 over 4 pi is 1. So this equation becomes 15 plus 2a equals 1 times 3a minus 10. So becomes 3a minus 2a equals 15 plus 10, or a equals 25. That's the solution. Next, number 5. Given that sine x plus 1 over 6 pi minus sine x minus 1 over 6 pi equals cosine x plus 1/3 pi minus cosine x minus 1/3 pi. Find the exact values of tangent x. We are going to find tangent x, right? Based on trigonometrical formula, I'm going to writing here that if sine a plus b equivalent with sine a cosine B plus cosine A sine B. If sine A minus B equivalent with sine A cosine B minus cosine A sine B. And if cosine A plus B equivalent with cosine A cosine B minus, not plus, minus sine A sine B. And if cosine A minus B, it is equivalent with cosine A cos B plus sine A sine B. Okay. And based on this information, I'm going to find this first. Okay. I'm going to apply into sine x plus 1 over 6 pi. It means based on this information. So it means sine, better if I'm going to I will use another color. Yeah. Yeah, sine x plus 1 over 6 pi equivalent with sine x cosine 1 over 6 pi plus cosine x sine 1 over 6 pi. This is cosine 1 over 6. Cosine 1 over 6 is square root 3 half sine x plus sine 1 over 6 is half cosine x. Okay. And after that, this sine x minus 1 over 6 pi equivalent with, like this, sine x cosine 1 over 6 pi minus cosine x sine 1 over 6 pi. It's going to be square root 3 over 2, half, okay, half cosine x. Correct. Sin x, this sin x, by this, half cosine x. Yeah. Next, cosine this. X plus 1/3 pi. It is cosine x cosine 1/3 pi minus sin x sine 1/3 pi. It becomes half cosine x minus square root 3 half sin x. And after that, sorry, yeah, this. It's going to be cosine x cosine 1/3 pi plus sine x sine 1/3 pi, equivalent with half cosine x plus square root 3 half sine x. And it means I'm going to writing based on this equation that square root 3 half sine x plus half cosine x minus square root 3 half sine x minus half cosine x equals half cosine x minus square root 3 half sine x minus half cosine x plus square root 3 half sine x. Becomes 0. Okay. And it means half plus half of 1 cosine x. Cosine x equals, this is minus and minus. So 2/2 becomes minus square root 3 sine x, or sine x over cosine x equals minus 1 over square root 3. So it means tangent x equals minus 1 over square root 3. So yeah, this tangent x, based on this question, yeah, we have to determine tangent x. Okay, next number, yeah, number, this one, number 5, number 6. Oh, B. Okay. This is, wait, this is 5A, next 5B. Hence, find the exact roots of the equation. Oh, find the exact roots of that equation. So, if tangent x equals minus 1 over square root 3, so x equals arctangent. X equals arctangent minus 1 over square root 3. So on a diagram, this, yeah, 1, 2, 3, 4. Okay. On this diagram, tangent values are positive on this quadrant and this quadrant. Yeah. quadrant 2 and quadrant 4. Yeah. Okay. On quadrant 2, if this angle is 1 over 6 pi, so this angle, yeah, is angle for pi minus 1 over 6 pi equals 5 over 6 pi. So x equals 5 over 6 pi. And as well, in this diagram, in this quadrant, I mean, as well, tangent is positive. So if this angle is 1 over 6 pi, it means this angle, okay, this angle is uh, 2 pi. 2 pi minus 1 over 6 pi. Wait, 2 pi minus 1 over 6 pi, it's going to be 12 over 6 pi minus 1 over 6 pi. It is 11 over 6 pi. So x equals 5 over 6 pi and 11 over 6 pi. Number 6, the parametric equations of a curve are x minus square root t plus 3 y equals ln 3. Okay. Then to obtain a simplified expression for dy dx, right? By chain rule, I think this. Okay, so x and y, I'm going to the chain rule like this. I'm going to writing this rule, dy dx equals dy dt times dt over dx. If y equals ln t, it means dy dx equals 1 over t. And if x equals square root t plus 3, so dx dt equals wait, t power half times half minus 1. Okay, half, okay, half t power minus half, okay, or 1 over 2, yeah, square root t, like this. So dt dx, opposite of this fraction becomes 2 square root t over 1. So dy dx equals dy dt times dt over dx. So it's going to be dy dt is 1 over 6, 1 over x, okay? And then 1 over t, I mean, here. Wait, I'm gonna check first. Yeah, this one. 1 over t. Wait, to make clear. 1 over t times 2 square root t becomes 2 square root t over t. And if I will multiply with square root t over square root t, it becomes 2 t over t square root t, or 2 over square root t. Now b, hence find the exact coordinate of the point on the curve at which the gradient of the normal is -2. So gradient or the derivative is -2. If -2, so if the gradient -2, it means dy, dy dx is the gradient, yeah, gradient of tangent, and then the gradient of normal straight line equals -2 based on this information, gradient of the normal. Yeah. So based on the rules that if two straight lines perpendicular each other, that m tangent times m normal, gradient of tangent times gradient normal equals -1. Okay. Or dy dx times -2 equals -1. So dy dx equals 1 over 2 equals half. Next, if dy dx equals half, it means, yeah, just now at the previous problem that dy dx equals 2 over square root t. So dy dx equals square root, 2 over square root t. I'm gonna move here. So it means 2 over square root t equals half, or square root t equals 4, and t equals 16 because 4 squared. So x equals square root t plus 3. 4 plus 3 because square root t equals 4 is 7. Y equals ln t. Based on this information, this x equals square root t plus 3 and y equals ln t. So it's going to be ln t equals 16. Ln 16. Yeah. So the coordinate point is 7, ln 16. This. Number 7, the variables x and theta satisfy the differential equation x over tangent theta dx d theta equals x squared plus 3. It is given that x equals 1 when theta equals 0. So when theta equals 0, so x equals 1. Solve the differential equation, obtaining an expression for x squared in terms of theta. Okay, so that equation x over tangent theta dx d theta equals x squared plus 3. I'm going to arrange this becomes multiply by tangent theta d theta. So it's going to be x dx equals x squared plus 3 times tangent theta d theta. And the next step, divide by x squared plus 3. This multiply. So it becomes x over x squared plus 3 equals tangent theta d theta. After that, both is integral. So it means if for the substitutions, here this integral, I'm going to find the integral of this x over dx here. This integral, if u equals x squared plus 3 du equals 2x dx, half du equals dx. So it means integral x over x squared plus 3 dx is integral du over u equals half ln u plus c, or half ln x squared plus 3 plus c. And integral tangent theta d theta, it is ln secant theta plus c. So integral x over x squared plus 3 dx equals integral tangent theta d theta. We can write things like this, half ln x squared plus 3 plus c equals ln. I'm going to change this becomes 1 over cosine theta plus c, already double c. And it's going to be ln x squared plus 3 or half, and it is ln cosine theta power negative 1 plus c. Okay, so it's gonna be ln square root x squared plus 3 minus ln cosine theta equals c, or c equals ln square root x squared plus 3 plus ln cos theta. So yeah, c equals, yeah, okay, when theta equals 0, x equals 1. So c equals ln 1 plus 3 plus ln cosine 0. So c equals ln square root 4 ln 2 plus ln 1, or c equals ln 2. So ln square root x squared plus 3 equals ln cosine theta plus c becomes ln x squared plus 3 equals ln cos theta, yeah, c equals ln 2. So it is, now this, oh yeah, this is minus ln cos theta ln 2 equals ln 2 minus ln cos theta. Becomes ln square root x squared plus 3 equals ln, based on the ln rule, 2 over cosine theta. So it means square root x squared plus 3 equals 2 over cosine theta, or x squared plus 3 equals 2 over cosine theta squared. X squared equals 4 over cosine square theta minus 3. Number 8. By sketching a suitable pair of graphs, show that the equation this square root x equals e power x minus 3 has only one root. Okay, I'm gonna sketch two graphs. Yeah, this one and this one. So firstly, y equals square root x. Three, okay, and I'm gonna find 4 coordinate point x, y, 0, if x 0, y 0 as well, because square root 0 is 0. If x equals 1, y 1 as well, so the coordinate point is 0, 0, 1, 1. If x equals 4, y equals 2. If x equals 9, y equals 3. So if you sketch so 0, 0 here, origin 1, 1 here, 4 and 2, 4 around here, 9 and 3, 4, 5, 6, 7, 9. So the graph will be like this, parabolic graph. And the second graph is y equals e power x minus 3. Two, 3, 4. Okay. I'm going to find 3 coordinate point x, y. If x 0, e power 0 minus 3 equals minus 2. If if y, yeah, if y equals 0, it means e power x minus 3 equals 0. So e power x equals 3. So x equals ln 3 equals 1.09. So 1.09 here. And if y equals minus 3, so x equals infinite or no solution. So if y equals minus 3, gonna be e power x minus 3 equals minus 3, e power x equals 0. So it becomes asymptote. 1, 2, 3. So asymptote line here. Okay, now we're going to sketch. This is 0, -2 and 1, 1.009 and 0 here. So the graph will be like this. The graph will be like this. Wait. Okay. That's the graph. This is the graph of y equals e power x minus 2. Meanwhile, this graph is graph of y equals square root x. Show by calculation that this root lies between 1 and 2, lies between 1 and 2. If x equals 1, y equal square root x plus square root 1, because x equals 1. So it is 1. So equation y equals e power x minus 3 equals e power 1 minus 3 is minus 0.28. So it is square root 1 greater than e power 1 minus 3. Compare this number. Now, if x equals 2, y equals square root x equals square root 2, 1.41, and y equals e power x minus 3, this equation equals e power 2 minus 3 equals 4.39. So if you compare this number and this number, that square root 2 less than e squared minus 3 if you compare this number. So we can state that since square root 1 greater than e minus 3 and square root 2 less than e power 2 minus 3, we can state that the root lies between 1 and 2. C. Show that if a sequence of values given by the iterative formula x n plus 1 equals ln 3 plus square root x n converges, then it converges to the root of the equations in option A. So if square root x equals e power x minus 3, so it means square root x plus 3 equals e power x. So if we give ln e power square root x plus 3 equals ln e power x. So ln e power square root x plus 3 equals e power x. So e power x equals square root x plus 3 ln e based on ln rule. Okay, so square root x equals e power x minus 3 because 3 moved to the left. Yeah, ln e equals 1. This d is the iterative formula to calculate the root correct to 2 decimal places. Give the result of each iteration to 4 decimal places. Right. If x0 equals 1, so x1 equals ln 3 plus square root 1, and it is, I have calculated already, 1.3863. x2 becomes ln 3 plus square root this number, 1.3863 equals 1.4297. x3 becomes ln 3 plus square root this number, 1.4297 is going to be 1.4341. x4 ln 3 plus square root 1.4341 equals 1.4345. x5 ln 3 plus square root 1.4345 equals 1.4345. x6 with the same procedure, you're gonna find the answer is 1.4345. So this the number. Number 9, the diagram shows the curve y equals x e power minus 1 over 4x squared for x greater than or equal 0 and its maximum point M. Find the exact coordinates of M. Right. So ay equals x e power minus 1 over 4 x squared. I'm going to find the differential because to get the maximum point, we can get the maximum point through the differentiation, the differential of the functions. So if y equals u times v, because these functions, there are two functions here, x and this function. So it means derivative u equals v times derivative u plus u times derivative v. So if u equals x, derivative u equals 1, if v equals e power minus quarter x squared, so derivative v equals minus half x e power minus quarter x squared. So derivative y or dy dx is e power minus 1 over 4 x squared times 1 plus x times minus half x e power minus a quarter x squared. So it becomes e power minus quarter x squared minus half x squared, because x times x, e power minus a quarter x squared. So it becomes factorize e power minus a quarter x squared 1 minus half x squared. So the maximum point when the first derivative equals 0, so maximum point happening when dy dx equals 0. So it means it should be 0. So if e power a quarter x squared times 1 minus half x squared equals 0, so there are two solutions. E power minus a quarter x squared equals 0, or 1 minus half x squared equals 0. And this one becomes minus a quarter x squared equals ln 0. So there is no solution for this part. Now this one becomes half x squared equals 1. So x squared equals 2. And x equals square root 2. So y equals x e power minus a quarter x squared So, and x equals square root 2. So y equals square root 2 e power minus a quarter x squared equals square root 2 e power minus half. Yeah, so the coordinate point, coordinate point is square root 2 x comma y is 1. Square root 2 e power minus half. Okay. So this becomes minus half because x squared is 2. So 2 times minus a quarter equals minus half. B, using the substitutions, x equals square root u, or otherwise find the integration by the exact area of the shaded region bounded by the curve, the x-axis and the line x3. Okay, so area equals 0, integral 0 to 3 of x e power minus a quarter x squared dx. But I'm going to find the indefinite integral first. Integral x e power a quarter x squared dx. So if x equals square root u, it means u equals x squared, and u equals 2x dx, or half du equals x dx. So it means this integral becomes half e power minus quarter x squared du. It becomes e power minus a quarter u du. And the integral becomes half times 4 minus 4 times minus 4 e power minus a quarter u plus c, or it becomes minus 2 e power minus a quarter u plus c. So integral 0 to 3 of x e power minus a quarter x squared dx comes integral 0 to 3 of minus 2e. This is the integral. U is x squared. Okay. So it becomes minus 2 times e power minus a quarter times 3 squared minus e power minus a quarter times 0 squared. So minus 2 times e power minus 9/4 minus 1 because e power 0. So it becomes 2 times minus e power minus 9/4 minus 1 or here or 2 times 1 minus 1 minus e power minus 9/4. The solution next 10. 10. Wait. Express fx in partial fraction. Okay. So 24x plus 13 over 1 minus 2x 2 plus x squared equivalent with a over 1 minus 2x plus b over 2 plus x 2 plus x squared here plus c over 2 plus x squared. And after that, multiply by 1 minus 2x 2 plus x squared becomes 24x plus 13 becomes a times 2x 2 plus 2 plus x squared b times 1 minus 2x times 2 plus x plus c times 1 minus 2x. A times 2 squared or 4 plus 4x plus x squared b times 2 plus x minus 4x minus 2x squared plus c minus 2cx. Multiply after that 4a plus 4ax plus ax squared to b plus bx minus 4bx minus 2bx squared plus c minus 2cx becomes a minus 2b x squared plus 4a minus 3b minus 2c x plus 4a plus 2b plus c. 24x plus 13. So a minus b equals 0. This is the first equation. And then 4a minus 3b minus 2c equals 24. The second equation, 4a plus 2b plus c equals 13 is the third equation. I'm going to find first through equation 2 and equation 3 for a minus 3b minus 2c equals 24. For a plus 2b plus c equals 13 minus 5b minus 3c equals 11. Yeah. The fourth equation. And then through 1 and 2, the first equation and second equation, a minus, this is 2b actually, like this, 2b equals 0. For a minus 3b minus 2c equals 24. I'm going to cancel a. It means we're gonna eliminate a times 4 times 1. For a minus 8b equals 0. For a minus 3b minus 2c equals 24. Eliminate a, 5b, 5b plus, because 0 minus 24. The fifth equation, through 4 and fifth equation, minus 5b minus 3c equals 11 minus 5b plus 2c equals minus 24. Minus 5c equals 35. So c equals minus 7. So minus 5b minus 3c equals 11. C equals minus 7, so minus 5b plus 21 equals 11. So minus 5b equals 11 minus 21 becomes minus 10. B equals 2. Continue here. A minus 2B equals 0. A minus 4 equals 0. So A equals 4. So A equals 4, B equals 2, and C equals minus 7. Next, hence obtain the expansions of fx in ascending powers of x up to and including the term in x squared. Okay, I will expand one by one. The first from 1 over 1 minus 2x. It is 1 minus 2x power minus 1, or it is 1 plus minus 2x power minus 1. And if we expand, it becomes 1 plus minus 1 times minus 2x over 1 factorial plus minus 1 times minus 2 over 2 factorial times minus 2x squared. And it becomes 1 plus 2x plus 4x squared plus so on. This the first. The second is 1 over 2 plus x. It is 2 plus x power negative 1. So I will change like this. 2 times 1 plus half x. Yeah. Power minus 1. Okay, then the expansion becomes half times 1 plus minus 1 times minus 1 over 1 factorial times x half for 1 and then plus minus 1 times minus 2 over 2 factorial times x half squared. So on, right? And the next is, oh yeah, it becomes half times 1 minus half x and then plus half x squared. And the third is 1 over 2 plus x squared, or 2 plus x power minus 2. Or I will change, it becomes like this. 2 times 1 plus half x yeah, power minus 2. Okay, so it is going to be 1/4 because 2 power negative 2, 1 plus minus 2 times x half, of course, power 1, plus minus 1 times minus 2, minus 2 times minus 3 over 2 factorials times x squared, yeah, x over 2 squared, plus so on, becomes 1/4 times 1 minus x plus 3/4 x squared, so on. Okay, and I recall that A, B, C, A is 4, 2 is B is 2, and 7, and C is minus 7. So the expression actually like this: 4 over 1 minus 2x plus 2 over 2 plus x plus minus 7 over 2 plus x squared. And it is 4 times 1 minus 2x power minus 1 plus 2 times 2 plus x power minus 1 minus 7 times 2 plus x power minus 2. So according to our expansion, 1, 2, 3, I'm going to write down like this, becomes 4 times expansion of this part, 4 times 1 plus 2x plus 4x squared plus 2 times expansion of this part, 2 times, 2 times half, actually 2 times half of 1 minus half x plus half x squared minus 7 times this expansion, 1/4 1/4 1 minus x plus 3/4 x squared. Continue here. After that, multiply 4 plus 8x plus 16x squared plus times half 1 minus half x plus half x squared plus it is minus because this is just now minus 7 this okay, this minus 7 so 7/4 plus 7/4 x minus 7 times 3 21 21 over 16 because 4 times 4 okay 4 times 4 next 4 plus 1 minus 7/4 I have calculated already 13/4 and then 8x minus half x plus 7/4 x is 37/4 x and then 16x squared plus half x squared minus 21/16 x squared is plus 239/16 x squared. This is the result. C. State the set of values of x for which the expansion in B is valid. Okay, so for 4/1 minus 2x, if x less than half, so the interval becomes x. Yeah, if it is modulus, it means minus and negative here. Yeah, so x greater than minus half, less than half. And if 2/2 plus x, if modulus x less than 2, it means x interval, yeah, x greater than negative 2, less than 2. So when modulus x less than half, the expansion is valid. 11. In the diagram, OABCDEFG is a cuboid in which OA equals 3 units, OC 2 units, OD 2 units. Unit vectors I, G, and K are parallel to OA, OD, and OC respectively. M is the midpoint of EF. Find the position vector of M. Okay. So OM, wait, OM, if I will draw on this figure, yeah, OM, this. the straight line. Okay, to find OM, it means 1I. Okay. OA, it means 3. Yeah. 3 units. And this is like OD, 2 units. And this one, oh, this is 1 unit. Yeah. 3, 2, 1. Okay. So OM, 3, 2, 1. Or 3I plus 2G plus 1K. This the position vector. The position vector of P is, yeah, position vector, just no position vector of M. And this one position vector of P is 1I plus 1J plus 2K. Calculate angle PAM. Angle PAM around here. One till here. 1 as well, and 2. Yeah, around here, P. PAM, it means PAM, AM. Okay. We're going to find the position vector. Calculate angle PAM. Angle PAM. Right. Angle PAM. So I'm gonna start from OA first. OA is 300. A. And then OM is 3, 2, 1. These are the position vector of P. Position vector should be arrows. Okay. OP equals 1, 1, 2. Right. So it means AP equals OP minus OA. It is 1, 1, 2. It's 1 minus OA is 1, 3, 0, 0. And it becomes minus 2, 1, 2. That is AP. And then AM equals OM minus OA. OM, OA, OP is position vector. That's our position vector. So it becomes OM, this 3, 2, 1. OA, which one? Which one? 3, 0, 0. So it is 0, 2, 1. This is AM. Next, AP times AM becomes minus 2, 1. 2 times 0, 2, 1. 0, 0 plus 2 plus 2 equals 4. And after that, modulus AP. Square root of minus 2 squared plus 1 squared plus 2 squared. Square root. Yeah, this 9 is 3. Yeah. AM. Modulus AM. Square root 0 squared, 2 squared plus 1 squared. Square root 5. And yeah, cosine theta is AP times AM over modulus AP times modulus AM. AP times AM is 1, 4. 4 over 3 times square root 5. It is, 4 over 3 square root 5. So theta is cosine power negative 1 of 4 over 3 square root 5. And I have a number 53.4 degrees. C, find the exact length of the perpendicular from P to the line passing through O and M. Oh, passing through O and M, it means, yeah, passing through O and M. If O is M, and yeah, P around here. So P, the straight line P and the straight line OM should be perpendicular each other. All right. So OM equals 3 to 1. OP is 1, 1, 2. And then OQ, this is Q. Yeah. So we don't know the distance O to Q, Q to M. Yeah. So we are going to find the distance P to Q. Yeah. So OQ is because it has scale, so T. I'm going to using T. TOM. OK is T of OM. That means T times 321. And PQ is, wait, Yeah, PQ is suppose OQ minus OP. It is 3T, 2T, and 1T. Sorry, someone disturbing me. 1, 1, 2. Okay, so it becomes, I'm gonna move here, PQ equals 3T minus 1, yeah, 3T minus 1, 2T minus 1, T minus 2. So OM times PQ should be 0. Yeah, OM is 3 to 1. PQ, which one? This 1, 3T minus 1, 2T minus 1, T minus 2 equals 0. So it becomes, yeah, multiply. So 9T minus 3 plus 2 times 2, 4T minus 2 plus 1 times T. T minus 2 equals 0. So 14, yeah, 14T minus 7 equals 0. T equals 7 over 14. So T equals half. PQ equals square root of 3 half minus 1 squared plus 1 minus 1 squared plus half minus 2 squared. So comes 1/4, 0. This is 3 half. 3 half squared, 9/4 is 10/4 or square root 10 half or half square root 10. This PQ. Okay, students, thank you for joining with me in this lesson. See you.